Yuri, please. Colleagues and friends, once again I'm happy to see you all. Thanks to Rakros that organized this useful and pleasant event. They travel all over the world and we tag along. I think I've visited 12 or maybe 13 countries together with Rakros already. So, moving on. Today I will tell you about new cameras and new systems of PhaseOne, which I represent here today as the Chief Scientific Advisor. PhaseOne is a Danish company with central offices, headquarters in Copenhagen, and it's scattered all over the world. It has offices in Latin America, Asia, Germany, and 3 design and production facilities. One in Copenhagen that designed professional studio cameras, PhaseOne. They're regarded to be the unrivaled on the market and the most expensive at that. Each costing 20 to 25, maybe even 30 grand. All the glossy magazines use those. Perhaps not every artist can afford those. They're used to process images. I mean the software. Israel designs and manufactures all design equipment and partly software, and all the optics are made in Japan at a factory owned by PhaseOne, which designs tailored optics for new sensors. They feature stability for photogrammetric processing. So 3 manufacturing units and 3 large units that support sales, and 50 distributors, some covering several countries. I will be focusing exclusively on aerial survey cameras, since studio cameras are not in focus of today's discussions. Currently, we are manufacturing OEM cameras to be integrated in the system, and ready-made systems. The top-line cameras, these 2, are standalone cameras. You can attach any peripheral equipment. I mean, you can put on them any other system or mount it on a drone or an aircraft, even without our peripheral equipment. Until recently, this took up the lion's share of the market. Until 2 years ago, PhaseOne did not produce the system. It only made cameras, and those cameras then went to large German integrators, IGI, and so on. There are also large Chinese integrators that make pentacameras for panoramic survey, so all of them use our cameras. Since last year we started making systems ourselves, so any camera can be part of a system now, and those systems are turnkey packages. It includes gyro, stabilizer, especially designed by a German company, GNSS, GPS module. We have integration capability with any system in the world. Our standard package uses one of the Aplanix device, but you can attach any other device. A new avenue that we embraced this year is machine vision, which is not related to aerial survey, but since we have excellent optics, it can be used in machine building, in inspecting the quality related to machine building. And one of the developments of the last year is integration with UAV or drones. We use DJI M600 drone, the most stable and consistent in the world. So we can deliver it as one package or deliver a camera separately, and then you will be able to use it in any other UAV. We have our own optics factory, so we design lenses. Somebody mentioned altitude restrictions when doing large area cities. These are the recent designs that we made. This is a 300 millimeter lens, which gives 5 centimeter GSD from 4,000 meters, which is not very bad if you consider, for example, surveying Moscow. The same cameras are used for ground objects, long-range inspection. I mean, if you have some objects you need to continually monitor, like nuclear power plants or defense facilities, you can utilize it. It comes in two forms, one with tripod, the other can be mounted on an aircraft. Sometimes there is a need to detect people in some secure applications, so it shows you what distance a lens should be placed with regard to an object of monitoring a face, to be able to do facial recognition of individuals who entered a given facility. This is typically used on the border between countries or to monitor various military facilities or nuclear power plants, power stations, and so on. This system is not new. It was issued last year or the year before that, 190 megapixel system consisting of dual lens, allowing you to acquire 190 megapixel image with focal length constant. I mean, it's not adjustable, it's 90 millimeters. Theoretically, even though we've never done it before, we could put in a 70 millimeter cameras. An interesting schematic was integrated here, and it is typical of our systems. It's a shifted sensor system. As you can see, they're shifted left and right versus the axis. So the left sensor captures the right side relative to flight, and the right one captures the left side. So when you seam these two together, the central projection is not compromised, which is essential for photogrammetry. So the resultant image is the central frame image that have been received using two CCDs with our technology. This system is used extensively in many countries. In particular, we had a lot of sales in the States. In Russia, we sold only one camera of this type. I hope it will continue. These cameras were issued last year. This one is based on a new sensor, CMOS sensor, which is the best in the game. New resolution, 376 and 4. CMOS delivers I can see this feature here. The dynamic range is 83 decibels, 83, 84. What's the benefit of it? You can survey, as Mikhail mentioned, with a high exposure rate. I mean, CMOS prevents you from frames per second. With CCD, it is possible using a CDI system. With CMOS, it's not possible. So you have to use mechanical system to legislate for frame shift, like in hexagon, or a system that reduces exposure, resulting in the minimum blur, because the dynamic range of sensors is very high. If we compare older CCD, it was 74 or something. Here it's 10 decibels higher, resulting in better quality. And the impact of lighting is not that great. I mean, you can fly more hours, you can fly under the cloud with all the other benefits that come with this camera. It weighs about 1 kilogram. Excluding the weight of lenses. The total weight will be slightly over 2 kilograms. The UAV cameras weigh even less. I'll show you later. This is a list of lenses we have at our disposal. 32 to 300 millimeters. You can use all of them. The most popular are 50 to 70.
There are companies who prefer 50 millimeters for urban imagery. So these are the lenses which are usually used by our users, but in fact you can use all of these lenses for photogrammetrical projects. These are the two new cameras developed specifically for UAVs. You can use it for UAVs, drones, any unmanned aerial vehicles. All of them are CMOS based. The difference between the two, they have their own dedicated lenses, and they're dust water resistant. Of course, you cannot shoot with it underwater, but it's like it's high water, fine water mist resistance, because when you're flying a drone, your camera is always closed up, is always open. In an aircraft it's closed, but in a UAV it is always open, exposed to the environment, and it's important for it to be resistant to dust, water, and other elements. They're very lightweight, and along with the lens, they weigh 1.1 kilos, and the dimensions are also compact. You can mount them on almost any UAV, and we have an integration kit accompanying this camera that allows you to do that, and a software to manage this, the flights, UAV flights, and to navigate the drone as well. These cameras are manufactured with 5 lenses. 5 lenses are possible, but 35 and 80 millimeter would be go-to lenses. This is a fixed focal length lenses. They're calibrated. They can be useful for the chromatic projects, and the lenses 80 and 150 millimeters are the changeable focal length lenses. They're used mostly for the inspection of sites, because for inspection, whenever you fly next to a large bridge or a turbine system or a power line, you need to focus your lens on different elements of that bridge. You're flying close to it, you need to focus on different elements of the bridge. That's why you cannot use a fixed focal length lens. We developed special lenses that can be focused on different sizes, and you can take a big bridge, for instance, and inspect the whole bridge, all its pillars and elements. Camera model, the distortion is less than half a pixel. Maximum distortion after correction is 0.5. And all the cameras are calibrated at our lab. We have a test field where we test the flight resilience of cameras, their navigation, and we check their accuracy. The typical accuracy is about 0.6, 0.5, 0.6 pixels, with 1 to 1.5 pixels in height, with 9 different control points for that field, testing field that we have. What I've already mentioned about FMC, we call it blue control technique. In other words, you can control the blur of the image with your shutter speed and the speed of the aircraft. Here you see an example. If we are flying with this kind of shutter speed and we allow the shift in 1 pixel, in Europe they allow up to 2 pixel shift, they think it is quite standard, then you can fly at a speed of 228 kilometers per hour, and your image will have a 5 centimeter resolution, and it will be quite okay image. Here you see the example of images. Here you see moving cars with a speed of 120 kilometers per hour. Same speedway in Israel, and the plane was flying at the speed of 167 kilometers per hour. And these cars were shot at the same time, and the relative speed is 287 kilometers per hour. And you cannot tell the difference between the cars moving in one and another direction. I'm coming to an end. These are the productivity tables here. These are the examples of images. This is a drone image with 1 centimeter resolution. Again, this is a drone flight. Again, 1 centimeter resolution. This is 1.2 centimeter resolution. This is airborne image, 2.3 centimeter resolution, 1.5 centimeters aircraft. This is a new camera, 150 megapixels. Again, that's what it looks like. This is the object inspection. Again, object inspection, we're talking about a wind turbine here, and different advantages that the camera PhaseOne has. Hopefully they're well known to you. Thank you very much.